Hi students, good morning. Welcome to my class. Today we have to discuss the represent the number line on the represent the real number of the number line. So let us discuss 3.765 is one of the real number. We have to represent it on a number line. We know that in the last classes we have to represent the irrational number on a number line. Today we have to discuss the represent the real number on a number line. So let us one of the example 3.765. So first we have to draw the one line. And mark the two centimeter as a 1 unit. 2 centimeter as a 1 unit. Okay, first .765 is lies between 3 and 4. So 3.0, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9 and 4.0. 4.0. Now 3.7 is lies between 3 and 4. Then 3.76 is lies between 3.7 and 3.8. 3.7 and 3.8. 3.76 is lies between 3.7 and 3.8. So we have to write the real number in between 3.7 and 3.8. Again draw the one line. Okay. Again take the scale and mark 2 centimeter is 1 unit. So 2 centimeter is equal to 1 unit. Take any suitable measurement. This is your convenient. Now 3.70, 3.71, 3.72, 3.73, 3.74, 3.75, 3.76, 3.77 and then 3.78, 3.79 and 3.80. This is 3.80. Now 3.76 is lies between the 3.7 and 3.8. Now 3.765. 765 is lies between 76 and 77. 3.76 and 3.77. So again I will write real numbers in between 3.76 and 3.77. Again draw the one line. Now take again scale same measurement. 2 cm is equal to 1 unit. Or 3 cm is equal to 1 unit. It is your convenient. You have to take any suitable measurement on a number line to represent the real number. Okay. Now 3.76 and 3.77. How many real number between 3.76 and 3.77? Let us find out. This is 3.760. Correct. Next, this is 3.761. This is 3.762. This is 3.763. 3.764. And this is 3.765, and this is 3.766, this is 3.765, 766, 767, and this is 3.768, and this is 3.769, and this is 3.770. This is 3.770. Now, our question is 3.765. Where it is? 3.765 is there. Okay. 3.765 is the real number. We have to represent it on a number line. So, like this problem, we have to draw the like this method. Okay. Next one, we have to discuss the next concepts. So, I will give the one example. We have to do in your home. 4.26 bar. You have to draw in your home. Okay. And another example. 8.426. Okay. These two are we have to draw in your home. This is for homework for you. Okay. Let us take the next concepts. Okay, students. In the next concepts, represent the root x for any given positive real number geometrically. How we are represent the root x for any given real numbers? X means any real numbers. For example, decimal numbers, fraction number, or any imperfect square numbers, anything. So I will take here x value decimal numbers. So first we have to study the rules of the representing the root x for any given real numbers or geometrically. So first we have to draw the one line. And I will mark A, and this is anything B. This length I will take as x. I will take as x. Now, and mark the C from the point B as a 1 centimeter. This is 1 unit. This mark is C. The mark C is from the point B as the length of 1 unit. You have to take 1 centimeter or 2 centimeter. It is your convenience. Okay? The next. Now, this is 1 unit. Next, AB as a x unit, BC as a 1 unit. Okay. Now, AC, we have to mark the midpoint of AC. We know that how to mark the midpoint in the 8th standard. We have to discuss the perpendicular line of any given line segment. So more than half, we have to take AC. So I will take more than half of the AC. So I will cut 1 mark up and below, and same distance we have to keep on the point C and cut the R. Now draw the line. We have to intersect, we have to join these two intersecting points, and then this line is intersect the AC. That point we call it as O. Next one, take the compass and AO as a radius or OC as a radius. Both are same. Now we have to draw the semicircle on point O. Now take the compass, protractor, and mark the 90 degree on the point B. We have to draw the perpendicular line from the point B. We have to join it. So this is called as D. This point is called as D. This line segment, this is called as root x. Now this one we have to prove it. Root x. This length become a root x. Now we have to prove in a geometrically. So now join the OD. Join the OD. Okay students, this is an geometrical concept. Now we have to discuss in mathematically how to prove that root x as BD as a root x. How it become a root x? We have to solve in a mathematically. So let us come to the how to discuss how to solve the mathematically of the root x of the length BD. So in triangle BOD is a right angle triangle. Is a right angle triangle because of angle B is a 90 degree. So OD and OC and OA. OA is equal to OC is equal to OD because of radii. Therefore OA, OC, OC and OD. We know that AB how much? X unit, BC is a 1 unit. I want AC. AC is a diameter of the semicircle. So AC is equal to AB plus BC. If you add these two lengths, AB plus BC, if you add these two lengths, we will get that AC. So AC is equal to, so AB how much? AB is equal to X unit plus BC is 1 unit. So X plus 1 unit. This is the length of AC is plus 1. I want AO or OD or OC, both are same. So I will take as a OD. OD is equal to, so the OD, OA and OC are the radii of the semicircle. So AC is a diameter and OD is a radius. Radius is a half of the diameter. Therefore, OD is equal to, what is the diameter here? X plus 1 by 2. So this is the OD. OD means radius. If it is the diameter is 10 centimeter, so OD is equal to 5 because of half of the 10. Here AC is equal to X plus 1 unit. Therefore, OD is equal to X plus 1 by 2, half of the X plus 1. Next, OD length I will take. Then OB I want. OB is equal to, OB ಬೇಕಂದ್ರೆ OC minus of OB. OC minus of BC. Then we will get the OB. So OB is equal to OC minus of BC. OC minus of BC. So what is an OC? OC is the radii. So radii how much? OD. OD and OC both are same. X plus 1 by 2. X plus 1 by 2 minus of BC how much? 1 unit. Therefore, OB is equal to, we have to take out the LCM of these two numbers. 2 into 1, 2. 1 into X plus 1, X plus 1. X plus 1 minus of 2 ones are 2. Whole upon 2. Therefore, OB is equal to X minus 2 plus 1 minus 1 by 2. So this is the value of OB. This is the length of OB is X minus 1 by 2. So the length of OD is X plus 1 by 2. These values are very important to apply to find out the BD. BD is root x. We know that, but we have to prove the mathematically. So BD is equal to, in triangle BOD, apply the Pythagoras theorem. So we know that Pythagoras theorem in the last year. What is that Pythagoras theorem? In a right angle triangle, the square of the hypotenuse is equal to sum of the squares of the other two sides of the triangle. So what is the hypotenuse here? OD. So we have to square it. OD square, it is equal to other two sides OB and BD. OB and BD are the other two sides of the triangle. This one we have to square and sum it. So OB square plus BD square. Now OD square how much? OD, here OD is there, X plus 1 by. So now we have to find the BD. So BD square you have to write here only. OB square I will send here. So OD square if you come this side means minus OB square. It is equal to remaining is BD square. Now OD square minus of OB square is equal to BD square. Otherwise BD square is equal to OD square minus of OB square. I will write on exchange of the BD square you have to write in the RHS side. OD square minus of OB square in the RHS side. No problem. Now BD square. We have to calculate the BD. So OD how much? OD X plus 1 by 2. X plus 1 by 2 whole square minus of OB how much? X minus 1 by 2 whole square. X plus 1 by 2 whole square minus of X minus 1 by 2 whole square. This is A square minus of B square format is there. So we know that A square minus of B square is equal to A plus B into A minus B. This is formula. So I will apply the formula. This is A square. A means X plus 1 by 2 plus this is A and B. X minus 1 by 2. A plus B into this is same X minus B. X plus 1 by 2, this is an A and this is B minus of X minus 1 by 2. We have to put bracket because of minus is there. Now X plus here denominator are same, add the numerator, plus 1 minus 1 get cancelled. minus x plus x get cancelled. Minus x plus x get cancelled. Remaining plus 1. Minus into minus plus 1. Plus 1 plus 1 plus 2. 2 by 2. So 2 to get cancelled. Here also 2 to get cancelled. Remaining bd square, it is equal to what will get remaining? Bd square, it is equal to x. I want bd. Bd is equal to root x. So this is for mathematically proof. So this is a geometrical proof. So any real numbers of root x for any given real numbers geometrically means we have to draw like this. So let us have the example. Let us take an example. Okay, students. Let us make the example. Represent root 9.3 on a number line. See, students, I will take x for 9.3. I told x is any real numbers, so I will take 9.3. In the last classes, root 2, root 3, root 5, root 7. So like that questions, like that real numbers, we have to represent it on a number line. We know that already we have discussed in the last classes. Today, 9.3 of any real numbers, I will take the decimal number. Decimal number, how to represent it on a number line? I showed in the last point geometrically concepts and the mathematical concepts. So we have to represent the root 9.3 on a number line. So how? See, first we have to draw the one line. So we have to mark any point that is called as A. So let's take the scale and 9.3 is there now. So that's why we have to draw the 9.3. This is called as B. This is 9.3. The length of AB is 9.3. So next step, we have to mark the C from the point B as a 1 unit. This is 1 unit, that is called as C. This is 1 centimeter. So 9.3 and this is 1 centimeter. This is 9.3 centimeter. Now, take the compass and now we have to mark the midpoint of AC. So we have to take the more than of. Now we have to join these two intersecting lines or in a dotted line. Okay. Now this mark is a midpoint, that is called as O. Now AO and OC are the same length. AO and OC are the same length. Okay. Now O as a center and draw the arc, semicircle. Draw the semicircle in the point O. Next, draw the 90 degree on the point B. And join the mark B. So that is called as B. This is called as root 9.3. So that one we have to draw it like this. So this is root 9.3. Okay. So we have to join the BD, the OD. Now we have to prove the mathematical. Now we have to, this one is a geometrical proof and we have to prove the mathematical. How? So we know that how much? OB if you want means OC minus of BC. OD we know that. OD how much? OD and OA and OC are the radii of the semicircles. Therefore, AC we know that AC is equal to 9.3 plus 1. 9.3 plus 1 how much? 10.3. So this is the value of AC. We want OD or OA and OC are same. OA is equal to OC is equal to and OD. It is equal to 10.3 by 2 because of these are radii of the semicircle. So radius is a half the diameter. So AC is a diameter. The length is 10.3 centimeter, and this is a OA, OC, and OD are the half of the 10.3. So it means 10.3 by 2. I will write that simplest form of 10.3 by 2. We have to write like this only. Now OB length we want. OB means OC minus of BC. OC minus of BC. So what is the OC? OC is this one. OC is 10.3 by 2 minus of BC. BC how much? 1 centimeter. So now let us simplify form. 2 1s are 2, 2 5s are 10. Next 2 1s are 2. Remaining 1. 10 is become, nothing is there, 0. 2 5s are 10. So 5.15 minus of 1. 5.15 minus of 1 is 4.15 centimeter. That is called as OB. Now we want to OBD. Let us apply the according to Pythagoras theorem. Pythagoras theorem. So here in the triangle OBD, in triangle OBD, angle B is equal to 90 degree. Okay. So let us apply the Pythagoras theorem. So what is that? OD square is equal to OB square minus of BD square. OB square minus of BD square. OD square is equal to OB square minus of BD square. This is that according to the Pythagoras theorem. So now we have to calculate the BD square. So this is not minus, this is plus. I want BD square. So BD square, OB square you have to move this to the LHS side. OD square, OB square if you come to the LHS side, it becomes minus OD square. It is equal to BD square. So OD square minus of OB square it is equal to BD square, or BD square it is equal to OD square minus of OB square. So that's it. So OD, what is the length of OD? OD. This is OD, 10.3 by 2. 10.3 by 2. So this is simple for 10.3 by 2 whole square minus of OB 4.15 whole square. We have to simplify for 2 1s are 2 5s are point, 2 1s are and 2 5s are 10. So 5.15 whole square minus of 4.15 whole square. So now BD square is equal to 5.15 whole square minus of 4.15 whole square. This is the A square minus of B square. Again apply the A plus B into A minus B. A square minus of B square formula. A plus B into A minus B. Here what is an A? 5.15 is an A and 4.15 is an B. So A plus B means 5.15 plus 4.15. 5.15 plus 4.15 into 5.15 minus of 4.15. So here 5.15 plus 4.15, if you add these two numbers, it becomes 9.30 or 3 into 5.15 minus of 4.15 means 1. So will do the one exam homework for you for this like this questions. Root 8.4 and root 7.5. We have to draw